does the consumer move along an indifference curve? Which point in an IC should Crusoe choose? And why does this IC have this particular shape? Those of you who like to practice previous year question papers would know this is a common question in the board exams. Why is it curved and not a straight line, right? We'll come to that. Crusoe can move from any point in an indifference curve to another point only by substituting at least one of the goods. Which means if he moves from 3-2 to 4-1, he has substituted one milk for one egg. This change in quantity is called delta for the product, and delta eggs by delta milk is called the rate of substitution between the two products. Or we can call it MRS2, marginal rate of substitution, but only if we consider it per unit. That is, movement on the curve is only 1 unit at a time. The rate of substitution, or MRS, is the amount of eggs that Crusoe is willing to give up for an extra unit of milk. It measures his willingness to pay for milk in terms of eggs. This is pretty important for us to figure out consumer behavior, okay? If you understood this example also well, then we can try out some algebra now. Let us use x1 and x2 to represent good 1 and good 2 instead of saying milk, eggs, etc. But all that we studied till now still remain the same. Let's try it out and see, right? Suppose there are two bundles represented by x1, x2, one bundle, and x1 plus delta x1 and x2 plus delta x2, another bundle. Why are we using delta x1, delta x2 here? Because as we move along the curve, x1 will change. That change is delta x1. And again, x2 will change. That change is delta x2. Now we know that monotonicity of preferences implies that if delta x1 is greater than 0, then delta x2 has to be less than 0. And if delta x1 is less than 0, then delta x2 has to be greater than 0. We also know that the consumer can move by substituting one good for the other. And just like the earlier cases, the rate of substitution between good 2 and good 1 is given by the absolute value of delta x2 by delta x1, right? Just like earlier we had delta eggs by delta milk. And this is of course just the algebraic way of saying that the rate of substitution, or the MRS, is the amount of good 1 that the consumer is willing to give up for an extra unit of good 2, right? Now comes the more important and interesting part. And for this, we have to bring back the graph. The more milk you have, the more you will be willing to give it up. If you're all the way here in the graph, you have a lot of milk, but very less eggs. Why? Remember utility? Since you have a lot of milk there, your marginal utility of each unit of milk is lower, whereas for each unit of egg is higher. So you're willing to give up more units of milk to get 1 unit of egg at that stage. So the curve is pretty steep here, as you can see. But as your number of milk bottles reduce, your utility for milk goes up, and the utility of eggs keep going down as you get more eggs. So as you go up, you're willing to trade less milk for eggs. So maybe it becomes 1 milk for 1 egg by around this part of the curve. Thus the graph starts changing shape again as the slope changes. At some point after this, the utility of eggs becomes more than the utility of milk. Then you're willing to trade less than 1 milk bottle for an egg, and the curve changes its shape again. Overall, we can say that as the amount of eggs with Crusoe increases, the rate of substitution between eggs and milk diminishes. Preferences of this kind are called convex preferences. And the curve is of course convex to the origin of the graph. And that's how the IC got its shape. An easier way to measure rate of substitution is just measure the slope of the IC at any given point. And the slope reduces across the IC curve, as you can see. So that is the concept of indifference curves. Now let's look at some properties of indifference curves. Let's list them out. First property, indifference curves are always convex to the origin due to diminishing marginal rate of substitution. 2. Indifference curves always slopes downwards. 3. Higher indifference curves always mean higher total utility. 4. Indifference curves can never intersect. Why? Otherwise, two ICs will pass through the same point. And what would happen then? At that point, the TU of IC1 and IC2 would have to be the same. And two ICs can never have the same TU. Each IC is supposed to represent a different total utility, right? And that's why intersection is not possible.